In a REM parasomnia, these are disorders during REM instead of non-REM. Here we're looking at a REM sleep behavioral disorder, and this one is actually more common in older males, unlike children for all the other disorders. In this case, these are people who normally when we're in REM state, we are actually paralyzed. We can't move. This prevents us from acting out our dreams. People with REM sleep behavioral disorder actually do act out their dreams. So in this case, this was an older man that was eventually brought into a sleep lab after he punched his wife in the middle of the night and gave her a black eye. We can take a look at his actions here. Shortly after waking him up, he reported that there was a tiger that he was fighting off. So he's actually dreaming about fighting a tiger, but his body is expressing disorder. This is another man in Japan who is currently asleep in a REM state, but he's acting out some sort of activity. I don't know, what do you think he's acting out? Well, when he woke up, he actually reported that he was having a fight with ninjas. Right? Notice one of the things that presents here that was not present in the non-REM is memory and cognitive content. In sleep terrors, the individual doesn't remember it, and there's no real content to it. Whereas in the REM sleep behavioral disorder, they tend to remember it, and there tends to be content to it. And the reverse of the sleep behavioral disorders, we get what's called sleep paralysis. Sleep paralysis emerges when we have partial awakenings in REM sleep, but that paralysis does not go away. So we're still stuck in a slight REM sleep. People who have sleep paralysis will often report being fully paralyzed, unable to move, panic-driven, difficulties breathing, pressure on their lungs. They often report seeing figures that may talk to them or whisper to them in strange languages. It's been known about for hundreds of years. In Renaissance, it was often painted as demons sitting on your chest, sucking your breath out. In modern times, many of the descriptions of alien abductions match sleep paralysis. Some people do not have the hallucinations. Some people have very dramatic ones. Right? But notice with sleep paralysis, we're still dealing with awareness and content. So whatever's going on in REM sleep involves using the brain, using the cortical processes, whereas non-REM involves having the cortical systems shut down. We know from fatal familial insomnia that getting REM sleep does not keep us alive. All the REM sleep in the world does not help us if we don't get non-REM. Non-REM is what we require to survive. So whatever is keeping us alive, whatever is required in sleep, and that keeps us functioning, that keeps our bodies going, tends to be occurring in non-REM sleep and somehow involves cortical shutdown. Whereas REM, whatever's happening in REM, does not involve cortical shutdown, but also doesn't seem to be necessary for survival. So if we zero in on this idea of the purpose of sleep, we have a few theories. Right? The first one, as we talked about, the inactivity theory, just says it's beneficial to be inactive at night. As we've talked about this doesn't make much sense. It doesn't match up with the evidence. Another common theory out there is called the energy conservation theory, which says that our brain consumes 10 to 30% of our energy requirements a day. And the only way to survive is to reduce energy consumption by shutting down the brain for long periods of time. Again, I'm not sure this really matches the evidence. I think one of the best explanations we have centers around the idea of restoration. We know when we sleep, this is when our tissue grows and repairs. This is when damage to our body is repaired. And this is when the brain starts to process and deal with the buildup of what we call adenosine. And I think adenosine is key to understanding the purpose of sleep. Adenosine is a byproduct of the use of ATP. Remember, ATP is the fuel that causes our neurons to fire, right? They activate the sodium-potassium pump. The sodium-potassium pump creates the energy differentials that allow neurons to fire, right? The sodium-potassium pump is ultimately what's responsible for the action potential and all of the neuro interactions in our brain, right? And ATP is the fuel of the sodium-potassium pump. As we break down ATP as a fuel, we ultimately wind up with a chemical called adenosine. And adenosine builds up the more we use our brain, the more we think, the more our neurons are active, the more adenosine we build up. Adenosine actually seems to be related to triggering the homeostatic sleep need. Neurons in our brain that tell us, hey, we are tired because we haven't slept in too long, seem to actually have receptors for adenosine. As adenosine concentrations rise, our need for sleep increases. In fact, caffeine that can often disrupt the homeostatic sleep need blocks adenosine receptors. So our brain seems to rely on the presence of adenosine and concentration of adenosine to trigger sleep. And the more adenosine we have, the more the brain says, hey, I have to sleep. And when looked at closely, adenosine turns out to be neurotoxic. Think of it as the waste product of the brain. Right? It is the end waste product of thought. And it can damage neurons, it can damage connections, and we have to get rid of it. Right? How do we get rid of our waste in general, right? We put it in the toilet and we flush it down. Turns out fluid, water, liquid is a great way to clean out waste. When things get dirty, when things get covered in waste, just wash them clean. And the brain does something very similar. In non-REM sleep, we activate cerebral spinal fluid. Red represents constricted diffusion, constricted flow. The cerebral spinal fluid isn't doing much. That green represented relatively fast-moving cerebral spinal fluid around the axons and neurons. Non-REM sleep is when we see the activation of the cerebral spinal fluid. The cerebral spinal fluid is actually washing clean the cortical tissue and the neurons of the adenosine. So why does this involve cortical shutdown? Well, it involves cortical shutdown because when we have fluid washing away all the chemicals around the neurons, what would that disrupt? How do neurons communicate with each other? Well, neurons communicate with each other with chemicals, the release of neurotransmitters. The cerebral spinal fluid washes away those neurotransmitters, causing the neurons to sort of shut down to their base firing level. Which is why the cortex can't regulate the limbic system. So when people awaken during non-REM state, we see this state of hyper-arousal, of terror, of anger, of violence, and even sexual expression. So ultimately, the argument is that the purpose of sleep is basically the rinse cycle of the brain.